Hi, so what you're watching is a walkthrough video of the T811 modular control board system. First of all, I'd like to apologize for the quality of this video. It was originally going to be done on this guy, but he died, so I'm stuck with my cell phone. And also a disclaimer, any parts you see in this video, these are 3D printed. This is not final quality. It'll be far superior. They're mold injected, and so you won't see any of these types of lines or like rough stuff. And these are also PLA, whereas the final parts are ABS, which are stronger and also more flexible. So yeah, so the basics of the T811 modular control board system is that it allows you to take your hardware pieces, attach them to your robot in a sturdy way that also permits modularity. So quick connection and just like that. So we're just going to break it down from there. So once again, quick connecting, just like that, modularity on your robot with your first hardware. So going to take it down a notch. The system works with two pieces. We have the mount and the cell. So the cell is the bottom piece. This goes on your robot, and then the mount has bolt holes for all your hardware pieces. Get to that later. Walkthrough of the cell. Cell has a couple features. The first one is the center hole. It's your mounting hole. That's just where you bolt it to your robot. It takes 1/4 and the top has a nut retainer so that you can put your nut on top and then come up from the bottom with a bolt and not have to use a wrench. And then you got your two clips. The two clips here go to the mount on top. You can see they're pretty flexible. It's more flexible with the ABS. Then what we have are the slots. So 4 slots in here. 1, 2, 3, 4. These slots go with these lips, so 1, 2 lips. And the lips just allow the cells to interlock together, create your grid system, your control board. We'll see that in a minute. And then one thing also I want to point out is this gap here and this gap here, what these pieces are for. It's for your Anderson power pole connectors. So teams can choose to use this, not use this. It's just an extra feature. So if you use these connectors like so, look something like this, the other side would be wired as well. It allows your wiring to be modular to your system. So your top piece would have your input and your output, right? So going to your motor, going to your power distribution board. So 2 wires, and you can lock them both in like this underneath your piece, just like that. So hold it, these notches hold the X and Y, so this isn't going anywhere. But as for the Z gets locked in once you install the mount. So we'll see that later. But now back to how the cells work on your robot. So obviously you need more than one of these. Your robot takes more than one motor controller, at least for now. Not a challenge, but go for it. What you want to do is when you have 2 cells, they just use the slot and lips, and they just lock together, just like this. You see, these aren't expanding. I'm applying pressure. They aren't going anywhere. Then you can just build your whole grid as you go. So building up your robot just like this. It's to be pointed out with this lip, you actually don't have to bolt down every cell. So once this is bolted down, that helps lock this one, and etc. Your call. But last year when we used it, we only bolted down every other one, and it worked fine, worked great. Stayed connected to our Lexan board underneath. And when you choose your board, you want to choose something strong. Lexan's a good material, but whatever floats your boat, wood obviously works, it's just heavier. However, it's also to be noted that these don't have to be used as a grid system. It's also designed for these lips to be drummed off really easily. So take a bandsaw or whatever to it, and take what you need. That way you can float 4 pieces, however your robot design dictates your ability to use, that's kind of what you follow, or design your robot around the system, your call. We kind of did a hybrid of the two, but it's up to teams. Then from there, let's talk about the mount. So the mount is your top piece. Quick walkthrough. We have all your bolt holes and your nut retainers. Check out online on the website. There's a design piece or design image showing you what goes where. So if you need help with that, go there. It shouldn't take you too long to figure out what goes where. This Victor wasn't designed for this, or this wasn't designed for the Victor 8084. This was prior to my use. It was just something I had lying around, so it actually kind of fit, which is kind of funny, but yeah. Then we have your 2 notches for attachment, and then you have your 2 extruded pieces here. This is for locking down your power pole connectors. So back to that, let's just take a look at what that looks like, and ta-da. So that guy goes there, not going anywhere, and especially after you yeah. So this guy locks it down, and he's not going anywhere. So, yeah. Also, one more thing with the strength. The strength only, you can see I can do this with one hand. It has to do with the practice, and I'm also pulling it from this side, the non-lip side. This side has more flex. I know some people are concerned by the strength involved, so I think I showed you earlier the shake test. This doesn't come off. The shaking you hear is actually the shake mostly between the Victor and the mount, because I don't have it tightly bolted. But also when you use it as a grid system, what happens is these parts get very close to each other, so it makes it harder for the lips to expand. So it holds it together tighter like this, but you can still get in with a screwdriver or whatnot, lock it, and disconnect it. So even in competition with the robot jogging around and getting hits, these parts never got disconnected. So good to go in that section. Now, how about what does the wiring look like? So I'm not really a wiring person, that's not what I did. But the way the system works with wiring is there's 4 areas for you to reach down. Right in here, there's a gap for your wires, so underneath your whole control board, you can route some of your wires, keep them protected, especially ones that you don't think you'll ever touch again, you know, power distribution ones, etc., etc. So what you can do is take your wires and just reach under like that, and then obviously you have your lockdowns, and even when you have a connector installed, you still have this gap space above to route your wires, so you can go any direction you need and make it work. So that's all based off how well you design your wires with your board, how intense you can get this wiring done. I think like 90% of our wires last year were within our control board, and it looked really nice, and judges loved it, and there was never like a concern of where your wires went or anything. But just make sure you have everything labeled so that you can test certain wires that I know kind of change every year as to what they want to know is connected where and what's working, so that's your call. Went through my intro. Okay, one final note. This system's kind of made to be a critical part of how you design your robot, so you want to design your robot with this Z distance increase for part height, etc., etc. But don't be afraid to get crazy with it. Don't be afraid to just kind of throw it on, because that's also what we did. It works great like that for your practice spot, to just be able to kind of throw things on and make things work, etc. You can refine it later. So that's your call. But also, like, go crazy. Try to figure out how you can make this work. Some teams were concerned how to use Z-axis height, and you can just bolt these together. Obviously, you might want to put a board in between so you can have it on your robot. But when you do it like this, you can have your power distribution board on 6 pieces on top, and then you can have 6 talon controllers or whatever you want on the bottom piece. And that's a very compact system for how you're powering your robot. Then also try to make it so your whole board can come out of your robot. That's what we did last year. Kind of like had something like this, notches on the sides, and we just slid it in and out, so that way we could work on a control board aside from our robot development, and you know, refine some of what the wiring was. So, and then that also allowed us to hold the control board back with the extra 20 pounds or whatever after bagging. So yeah, take it to a whole new level. Thank you for watching this video. Hopefully it answers all your questions. If not, don't be afraid to email me. But yeah, good luck, teams.